So this question says, in the xy plane, and I'm going to just draw an xy plane as soon as I read that because of my strategy here, plug in picture, which is just draw anything that's described in a question that can be drawn, you want to draw it. So in the xy plane, the graph of y equals 3x squared minus 14x intersects the graph of y equals x at the points 0, 0, and a. So let's do some work here. So we know we have an intersection here at the origin. That's my 0, 0. And we know we have an intersection here at a. And we know that we have a line y equals x, which is actually going to go through these points. So that makes sense, actually. That's my y equals x graph. And we know we have a parabola, this y equals 3x squared minus 14x. And I'm not going to get into the actual, graph of this and finding actual points and whatnot, although technically you could put this into your calculator or into your graphing calculator. You can graph both of these things, which is a very valuable idea. It may help you to answer this question much faster than what I'm doing here. So you can definitely throw both of these into your graphing calculator. But what I can assume is that, hey, this parabola has a positive 3 in front of the x squared, so that tells me that it's pointing upward. There isn't any vertical shift here, right? There's no plus some whole number or minus some whole number. So my parabola is going to be upward facing, and it's going to go through the origin. So it's going to look something like, and I'll just use a blue line, something like this. So that's my parabola. And that way, here, this visual kind of indicates, hey, yeah, we have an intersection here at the origin, and we also have an intersection here at this a, comma a. So the question is just simply asking, well, what's the value of a, right? What is this value here? What is this a value there? Now, one thing we should know, especially if you're not going to use a graphing calculator, is in order for two graphs to intersect, those two graphs must be equal to each other, right? So intersection means equal. So when I have the equation y equals x, and I also have the equation y equals 3x squared minus 14x, what I can do is combine those equations and say, hey, well, if y is equal to x, I can take this x from here down to here, replace that y with an x, which would lead me to have a single equation which says x is equal to 3x squared minus 14x. And now I just have to simplify this because I know that my x answer is actually going to be a, right? Because this is my x axis here. So my x solution here really will be an a value. So let's simplify this. I'm going to subtract x from both sides. So I'm left with 0 equals 3x squared minus 15x. I am going to, let's see, I'm going to actually divide both sides by 3, leaving me with 0 equals x squared minus 5x. Now I'm going to factor this x squared minus 5x. I'm going to pull out a GCF. The GCF is x. So I have x parentheses, x minus 5 equals 0. And then anytime I have a product equaling 0 like this, I can just set each component of that product equal to 0. So I'd have x equals 0. I'd also have x minus 5 equals 0. And of course, with the x minus 5, I solve for x by adding 5 to both sides, leaving me with x equals 5. So here are my two x solutions, which don't forget really are, right? They're really a solutions, right? So really a equals 0 and a equals 5. Well, we already knew about the a equaling 0 part. That's the origin here. So the a equals 5 is the a that we're looking for here, which means that our final answer here must be 5.